Hi guys, welcome back. So in this video we're solving this past final exam. Okay, so let's get started. Okay, so this is the first question that we have over here. It says find the equation of the plane containing the point that is perpendicular to the line of intersection of two planes. Okay, so we have this equation number 1 and equation number 2 over here. So this is the normal vector given to us to the first plane and the normal vector given to us for the second plane. Okay, and we need to find the directional vector in order to find the the plane that is perpendicular to the intersection of these two planes. Okay, so let's go ahead and do that. So for this we have these two, so we're going to cross product these two normal vectors. Okay, so if we do that, this is how we do it: I, J, K. And since you're cross producting N1 cross N2, so make sure to write N1 first. You cannot write N2 first, otherwise you'll get a wrong answer. Okay, so N1 first. Okay, so we're taking only the numbers over here. Okay, so ignore the variables for now. -1, 1, -8, that's 3, -1, and 2. Alright, once we have this, it's really simple to take the cross product. So what you're going to do first, you're going to cross out the I hat, the column, and the row. Okay, so once you cross this out, you're just going to multiply in this direction, like top to bottom, and then negative bottom to top. Okay, so just like that, crossing out the ith row, multiplying this, negative this. So if you multiply this times this, that's 2, and this is 8. Okay, so you do 2, and then negative, that's a positive, but it's negative multiplied by 8, so that's gonna be 8 I hat. Okay, similarly you do the rest. So you're going to cross out the j row and column. Okay, so we're gonna get 2 and 24. And yeah, it's negative j always. Okay, so this is positive, this is negative, but this is positive. Okay, so always remember this is negative j. 2 plus 24 plus k hat, and then for the k hat you do the same thing, crossing out this times this times this, which is gonna give you okay. Now if you do the math, so then this gives you -6 I hat, and this negative multiplies the inside, so then it becomes -2 j hat and -2 k hat. Okay, so this is your normal vector now. And to know the equation of the plane containing the point, so you're going to take this normal vector, okay, and plug in into the equation of the plane. So the equation of the plane is something like x minus x0, and here comes our vector, the components of the vector that you have, and then you're gonna do the same thing, and then here you're gonna have 22, and then here it's gonna be y minus y0, and -2 z minus z0 equals to 0. And this x0, y0, and z0, it's nothing but simply the point that is already given to us in the question. So 1, 7, -1. So our point is 1, 7, -1. So this is x, this is y, this is z. So x0 replaces 1. y0 is replaced with 7. And -1, negative, that makes a positive. So then here we have 1. And you can leave your answer like this. This is the equation of the plane that we were asked to find. Or you can multiply this, and your final result turns out to be 3x 11y plus z is equals to 79. So like I said before, you can leave your answer to be like this, or if you want to simplify it a little bit, so this is your final answer. Alright, let's move on to the second question. Alright, this is our second question, and what are we asked to find? So first of all, we're given this vector function over here, and we're asked to find the tangential component and the normal component of acceleration, and lastly we need to find the curvature as well. So we're looking for a tan, a normal, and the curvature. These are the things that we're looking for. So first, let's go ahead and calculate a tan. Okay, so this is the formula sheet given to us with the exam. I have posted this formula sheet in the description below. You can check it out. Okay, so we need to find a tan. So let's go ahead and find the formula for a tan. So here, it's given over here. So we can find it using V dot A, magnitude of V. Okay, so I just wrote the formula here. And now, to find V, we have this R over here, the position vector. And in order to find V, we're simply going to take the derivative of it, right? To find the velocity. Okay, so let's go ahead and derive this. So if you do that, so then the 2 becomes down, right? So then this 2 and 2 cancels out, and you subtract 1 from the t. So then you're only left with t I hat plus, and 3 comes down, and 3 cancels out, and subtract 1 from the t. So that's t squared j hat. And similarly you do over here, and you're left with negative tk hat. So this is the velocity vector. Now if you want to find the acceleration, so to find the acceleration, we can simply take the second derivative of the position vector, or you can derive the velocity vector once, since it is velocity as well, right? You can simply take the first derivative of the velocity or the second derivative of the position vector in order to get the velocity, the acceleration. Okay, so we're gonna go ahead and take the first derivative of the velocity since we already have it. So let's go ahead and do this. So if you take the derivative of 1, that's a constant, that's a variable, so it's gonna be 1. That is gonna be 2t, that's really simple, and this is gonna be negative 1, so we're just gonna write k. Okay, so now that we have v and over a over here, we can plug in here, or let's go ahead and find the magnitude of v first. Okay, so the magnitude of v is nothing, we already have v over here, we need to find the magnitude of v. And how do we do that? We're going to square each component. Okay, and then we're going to square root the whole thing. That is already squared. Okay, now squaring the whole thing. So then this is gonna give you t squared plus t to the power of 4 plus t squared, square root the whole thing. Okay, and now you can see you have 2t squared, so you have 2t squared plus t to the power of 4 and square root, and you guys can see you can factor out a t squared in here. Okay, so let's go ahead and factor out t squared. So you're gonna left with 2 plus t squared. Okay, and now if you square root it, so square and square root cancels out, so you're only left with t over here, and then you have square root of t plus 2 plus t squared. Okay, and you cannot simplify it further, so that means this is your magnitude of v. Okay, now it's nothing but simply to plug in everything into the formula v dot a. So if you do v dot a, so this is our v and this is our a, so let me go ahead and write it over here. Okay, next we need to v dot a. So how do we do the dot product? We simply multiply the I component with the I component, okay, and the j component with the j component, okay, and the k component with the k component, and we sum the result. Okay, so t times 1, that is going to be t, plus t squared times 2t, that is going to be 2t cubed, and then you have negative and negative, that's a positive, times t, that's 1, and you ignore the I, j, k in the dot product. Okay, so this gives you 2t cubed plus 2t for v dot a. Okay, So here you got this v dot a and you have the magnitude. So let's go ahead and find a tan. So the a tan is equals to v dot a, which we got over here, 3q plus 2t over magnitude of v, which we found here, t over 2 plus t squared. Okay, so now let's see if we can simplify further. So yeah, we can simplify further if we factor out the t from the above equation. Okay, so let's go ahead and do this. So if we factor out the t, so we get 2t squared plus 2, and at the bottom we have t. So now you guys can see why I factored out the t in order to be able to cancel out with this t. Okay, so now that we cancel the t with this, so now this is our final answer for a tan without the t. Okay, now let's go ahead and find a normal. Okay, so if you look at the formula sheet, you can find out that the formula for a normal is v cross product with a and magnitude of it and divided by the magnitude of v. Okay, so let's go ahead and do the v cross a. We already have v, we already have a, and we simply need to do the cross product of it. And remember, for the cross product, we always write the first one first. So it's v dot a, so we're going to write the components of v first. If you write the components of a first, you're not gonna get the correct answer. Okay, so make sure to not forget this. Okay, so let's go ahead and write the components of v, which is t squared, negative t, and here we have 1, 2t, and negative 1. Okay, so if we take the determinant of this one, so of course we are cancelling out the I and I, the column of I hat and the row of I hat, and then we're going to multiply this times this and then negative this times this. Okay, so let's write out the result. So if you do this, so then it's gonna give you negative t squared plus 2t squared I hat. Okay, so what I simply did, I just crossed out I and I, the row and the column of I, then I simply did negative t squared and then negative cancels out, positive 2t squared. Okay, now we're gonna do the same thing with the j. So we're gonna cross out the column and the row of j and then multiply this, so that's negative t and that's negative positive t. Okay, so that is gonna be negative t, positive t. And yeah, remember, it's positive for the I hat, negative for the j hat, and positive for the k hat. So positive, negative, positive. So always for the j hat, it's negative. Okay. So now for the k hat, we're going to cross out the column and the row for the k hat and multiply this. So this gives you 2t squared negative t squared. So that's 2t squared negative t squared. Okay, so then if you do the math, this gives you t squared plus, that's a 0 j hat, and this gives you t squared k hat. So since it's 0, you don't need to write it, so you have, oops, I forgot the I hat. So that's t squared I hat plus t squared k hat for the v cross a. But the formula asks you to find the magnitude of v cross a. So let's go ahead and find the magnitude of v cross a. So if you do the magnitude of this, so then this gives you t squared. You're going to square each component, right? And then square root the whole thing. So that becomes t to the power of 4 plus t to the power of 4. So you get 2t to the power of 4 and square root of this. So then you get square root of 2 t squared. So v cross a magnitude, you got this. Okay, square root of 2 t squared. Now you're just going to divide it by the magnitude of V. So let's go ahead and divide it by the magnitude of V to find AN. So here we have square root of 2t squared divided by magnitude of V. So what did we get for magnitude of V when we calculated? So we get t square root of 2 plus t squared. T square root of 2 plus t squared. Okay, so we can do the division. Here we have t squared, here we have t. So let's go ahead and subtract t squared from t. So you get t only at the top. So this is your final answer for A normal. AN. And this was our A10. Now we need to find the curvature K. Alright, let's go ahead and find the kappa, the curvature. Okay, so for this we need r prime of t. R prime of t is nothing but the v. So this is v, and r prime prime of v, that's a double derivative with respect to position, which is equals to acceleration. So this is actually equals to v cross a magnitude, which we have already calculated, remember? And here this is nothing but simply the magnitude of v to the power of q, 3. Okay, so we already have these things, so we don't need to do any calculations. Okay, so v cross a magnitude, we already have it, which is equals to square root of 2 t squared. And what about the magnitude of v? So the magnitude of v, we have it as 2 plus t squared. Oops, that was after the simplification. It was originally t. Yeah, it was originally with t. Okay, so now we need to make it to the power of 3. Okay, so this has to be to the power of 3. And this completes your answer. And just to make it look a little simpler, you know, if something is to the power of 3, and here you are originally it's x to the power of a half, because square root of x is equivalent to x to the power of half, and then you are making it to the power of 3. So these have to multiply, half times 3, that equals to x to the power of 3 over 2. So you can actually accurate. Okay, so you can actually make this equal to, okay, so this has to be 3 to the t to the power of 3, and this is 2 plus t squared 3 over 2. Okay, so this is how you're gonna write it, and this completes our problem. Okay, let's move on to the next problem now. Oh wait, I have just realized we can actually factor out the t's over here. Okay, so this is t to the power t squared, and this is t cubed. So if you subtract it, so then 2 negative 3, that's a negative 1 at the bottom, so which means you have a t at the bottom, 2 plus t squared 3 over 2, and here square root of 2, and here you have nothing because it cancels out with the bottom. So the final answer is this. It is all simplified. If the question asks you to simplify, then you can go ahead and simplify it. Otherwise, this is also the correct answer. Okay, so we're actually done with everything that the question asked us to do. A tan, AN, and K. Okay, so now we can finally move on to the next question. Okay, so next we have this question number 3 over here, but I'm not gonna go ahead and solve this in this part. I'll be solving it in the next part of this video. Okay, so for now you guys can solve it and let me know the answer to this in the comment section below. Alright, so let's move on to question number 4. Okay, so in this problem, we need to use Green's theorem to evaluate the line integral given by this equation, where C is the boundary of the region given by the graph. these graphs. Okay, so for this one we are given that we need to use Green's theorem. Okay, and for the Green's theorem, if you guys don't know the formula, let me give you. It is always, you're going to make this equation, you're going to integrate this equation with respect to qx minus py. Okay, this is how you're going to do it, and this is your domain, and you need to do dA. Okay, so this is how you do it, and to find the region you will need to graph these two equations and figure out the region. Okay, so let's go ahead and do this qx minus py. And yeah, by the way, if you forget this qx minus py for the Green's theorem equation, you can always do this in the exam. Okay, so remember the p, it's always associated with the x component, and the y is associated, q is associated with the y component. Okay, so p with x, q with y, and you're simply gonna do the inverse determinant. In the determinant you go in this direction, right? So but in the Green's theorem you would simply go in the inverse determinant direction. So qx negative py. Okay, so you always go like bottom to top and then top to bottom. So you simply have to do like this in the exam. If you forget the equation, so you get qx minus py. It's as simple as this one. Okay, so let's go ahead and solve it. So this is our p, since it's associated with the x component, and with the y it's q. So first of all we need to find q with respect to x, which means partial derivative of q with respect to x. Okay, which means the y component is constant over here. Okay, so y is constant, so that goes to 0, and we're only differentiating x. The derivative of x, it's 1. Okay, and now we have negative py, the derivative of p with respect to y. So we are only differentiating y, and here x is treated as a constant. Okay, so x is a constant, so that is 0, and this 2x remains over there since it's a constant, and the derivative of y, it's 1. So you only have 2x over here. Oops, why did I put it in pink? Okay, 2x. Now to get the region, you need to draw it, right? So the first equation that you have over here, it's this one, and the second one is this one. Okay, so let's go ahead and draw this equation first, because it's already in terms of y equals to. So y equals to x squared, you guys already know it from high school. It's nothing but a parabola. Okay, okay, so now we have x equals to y squared. So it's x equals to y squared. So let's make it into y squared something. So in order to isolate y, we just need to square root both sides. So if we square root both sides, here we only have y, and here we're gonna have square root of y. So our equation, this equation turns into y equals to square root of x. Okay, and y equals to square root of x, it's nothing but simply a line something like this. Okay, so now you can see that this is y equals to x squared, and this equation is y equals to x squared. That was square root, and this is square. Okay, so this means our region is the intersection of these two graphs, which is this region over here. Okay, so now it's your choice if whether you want to go in the dx direction first, or you want to go in the dy direction first. It doesn't matter in this problem, because you're always between these two regions. Okay, here you're not changing, so it doesn't matter whether you choose to go in the x direction first or in the y direction first. It's gonna give you the completely same answer. Okay, so let's go ahead and go in the dx direction. Okay, so if we go in the dx direction, remember I told you in my previous videos for the Green's theorem, if you wish to go in the x direction first, then you go from left to right in this direction. But if you wish to go in the dy direction, then you go from bottom to top. Okay, so since we're going in the dx direction, we're gonna go in this way. Okay, so let's go ahead and find the equation of this line and the equation of this line. So this is our lower limit and this is our upper limit. Okay, so what is the equation of this line over here? So this line over here, it's y equals to square root of x, but we don't need it in terms of y, we need it in terms of x. So you guys see this equation in terms of x, it's already given to us, x equals to y squared. So we're gonna write x equals to y squared, okay? So that's our lower limit. And we're going in the dx direction first, and next we're going in the dy. Okay, so then this has to be y equals to something. Let me just change colors. Okay, dy, and this has to be y equals to something, y equals to something, and this is gonna be x equals to something for the upper limit as well. So now we need to know the equation of this line. This line we know x equals to y squared, and what about this line? Here we have this equation y equals to x squared in terms of y, but we need it in terms of x, okay? So we have this equation, but we need it in terms of x. So to I squared x, we're simply going to square root both sides. So we get square root of y equals to x for this equation. Okay, so we got our upper limit as x equal to square root of y. Okay, now for the dy, you don't need any equations for the dy. Remember, since it's the last variable over here, always has to be constant. This can never be an equation, otherwise you can never solve the problem. Okay, so for these, you don't go and follow the arrow, you only look at the region where does it belong, or where does our region belong in terms of y. Okay, so this is x values, this is y values, so our region goes from 0 to this point over here, so the intersection point of these two graphs. And we need to figure out what is this point over here then. So our lower limit is 0, but to know this, we need to find the intersection of these two lines. Okay, so for this we need the equation of these two lines. So these two lines were given the equation x equals to y squared and y equals to x squared. Okay, so we're given our first equation as x equals to y squared, and the second one as y equals to x squared. Okay, so you guys see this is x equals to y squared, the first equation. So we can use the substitution method here. We can replace this y with this equation over here, because it says y equal to x squared. So let's go ahead and replace this y with this one. Okay, so here if we replace this y equals to x squared, so here we're left with x squared, but here there was already a squared over here, so let's just square it. So then it becomes x to the power of 4. Now bringing the 4 to the other side, we have x to the power of 4 minus x equals to 0. And can we factor something from here? Yeah, there's a common x over here. Okay, so we can factor out an x from here. So here we're left with 1, and here x times x to the power of 3 gives us x to the power of 4. Remember, we add the exponent when we multiply. Yeah, so this is how we do it. Now we can make this x equals to 0, and this 1 minus x to the power of cube equals to 0. So we have two equations over here. So for this one, we get answer as x equals to 0 is the intersection point of these two graphs, which indeed is correct. Remember, because they both start at 0. And now for the other one, we have negative x squared. And what about moving this one to the other side? So if we move this one to the other side, negative cancels out. So we have x to the power of cube is equals to 1. And now we can just cube root each side. Okay, and so here we're only going to be left with x, and if we cube root 1, that's simply 1, right? So our answer is x equals to 0 and x equals to 1. So our missing value, the intersection point, is x equals to, so we found the x value as 1, so that means this is 1. So what about the y value? So let's plug in 1 into any of the equation that we have over here. So here, this is our first equation, this is our second equation. So if we plug in 1 in this equation, so if you square 1, it's the same thing, right? It doesn't change. So you got your intersection point as 1, 1. X value is 1 and the y value is 1 as well. So this is your intersection point for the two graphs. So you got your y value now as 1. Okay, so here this completes our setup of the Green's theorem. So now you can finally solve this equation. Okay, so let's go ahead and solve it over here. So we have y equals to 0 to y equals to 1. So let me copy paste it and come back to you. Okay, so I have written it. Now let's go ahead and integrate this with respect to dx. Okay, so this is a constant, so x, and now this is x squared over 2, and 2 and 2 cancels out, and you are integrating with x equals to y and x equals to y squared. And yeah, not forgetting these, if you want you can put them at the end as well. Okay, so now what is our next step? Our next step is to plug in these x equals to y squared and x equals to y x equals to square root of y and x equals to y squared into this axis. Okay, so first let's plug in y squared in at the place of x, right? So we are plugging square root of y. We're replacing this x with this one. Okay, and if there was a square already over here, and next we're going to subtract it from by plugging y squared inside this equation. Okay, so plugging y squared, and here we're gonna plug y squared, but there's already a squared over here. Okay, so then, and at the end, not forgetting the integral with respect to dy, we still have to do it. Okay, so now you guys can see the square and square root cancel out, and this is gonna become to the power of 4. So we have square root of y, negative y, and negative y squared, and this negative multiplies the inside, so that it's going to become negative y squared and then positive y to the power of 4, right? 2 to 4. So now you can finally go ahead and integrate it with respect to dy, because you only have y's over here and you only have dy left over here. So this is x square root of y, which is same as y to the power of a half. Okay, and if you go ahead and plus 1 to it, so it becomes y to the power of 3 over 2 divided by 3 over 2. Okay, and this is 1, so then it becomes y squared over 2 negative y to the power of 3 over 3 plus y to the power of 5 over 5 from 1 to 0. Evaluating from 1 to 0. If you plug in 0, you're gonna get 0 in all this, so no need to do it. So only plug in 1 over here, so you get 1 divided by 3 over 2, and you have plus, oh wait, why did I change the values? It was already a minus over here. Okay, minus, plus, yeah, that's good now. Okay, so you have half negative 1 over 3 plus 1 over 5. So if you do the math here, you get 2 over 3, negative a half, negative 1 over 3 plus 1 over 5, and this should give you a final answer as 1 over 30. Alright, so this is the answer to this problem, the Green's theorem problem, question number 4. So let's move on to the next question over here. Okay, so here we need to test whether the vector field is conservative or not. If it's conservative, then we can go ahead and find its potential work done, right? Because if it's not conservative, then we cannot find it. Okay, so then this next part you don't need to do it. You simply have to say that it's not conservative. Okay, but in the case it's conservative, then we're gonna go ahead and solve it. Okay, so let's see if it's conservative or not. But the chances are that it's conservative, because of course they want you to do more work in the exam, because this question is worth like 10 points, and of course they just want you to solve a part of it and not the second part. Okay, so let's go ahead. If you're try to prove if you're correct by saying it's conservative or not. Okay, so this is P, this is Q, and this is R, because P is associated with the I component, Q with Y, and R with Z. Okay, and there is this equation that you need to know for the to find whether it's conservative or not. You need to prove that the curl of f is equals to 0, and this is the equation to find the curl. Okay, so this is the equation, but this equation is not given into the formula sheet. So if you head over to the formula sheet and look at it, you see there's no equation to find the curl of f. So that means you need to memorize this equation. But it's a really long equation to memorize, so let me show you a little trick so you don't need to memorize it. Okay, so like I said before, the P is associated with the X component, the Q with the Y, and R with the Z. So that's the only thing that you need to know. For the rest, that's really simple to derive at this equation. So first of all, we're in the I hat, right, which means we're in the X component. So let's go ahead and remove the X component. So what are we left with? We're only left with this. So in the determinant, if you're finding the determinant, you go in this direction, right? So you're in here, you're just gonna go in the inverse direction of the determinant, which means bottom to top, and then you're gonna do negative top to bottom. So that's it. You only need to remember bottom to top, top to bottom. Okay, like the inverse direction of determinant, because in the determinant you go in this direction first. Oops, sorry, I made a mistake. Okay, so in the determinant you go in this direction, right? But here you're going in the opposite direction, in the RY direction first, the bottom to top and then top to bottom. Okay, so RY minus QZ for the I hat, and next what do we have for the J hat then? For the J hat, remember it's always negative for the J hat. Okay, this is something that you need to know. For the I hat, that's always positive, and for the J hat, that's always negative, and for the K hat, it's positive. Okay, so for the J hat, since it belongs to the Y component, we're going to cross out the Y component and as always go in the inverse direction of the determinant from bottom to top first. So we have Rx and then negative PZ. And next we have K hat. So you're going to do the same thing, passing out the Z component, and you're going to go from bottom to top and then negative top to bottom. So QX minus QY. So you see, you did derive at this exact same equation, so you don't need to memorize it. But if you want, you're free to memorize. Okay, now that we have this curl equation, let's go ahead and find the missing piece. So in order to prove that curl f equals to 0, so all these components have to be equal to 0. So Ry has to be equal to Qz in order to make this equals to 0. Okay, so let's go ahead and calculate Ry. So Ry is nothing but simply the partial derivative of R with respect to Y. Okay, so this is R over here, and we are calculating the partial derivative of R with respect to Y. Okay, so this is what Ry means. So R over here, let me write it over here. R is X cosine xz. So if we derive it with respect to Y, which means X and Z are constants. Okay, you guys see X and Z are constant, so this whole equation is constant. There is no Y over here, which means it's equals to 0. Now QZ, so if you go ahead and find QZ, that should be equal to 0 as well. If it's not 0, that means you have made a mistake. Okay, so let's go ahead and check Q. So Q is this one, e to the power of Y, and we're differentiating with respect to Z. There's no Z over here, only Y, which means it's a constant. And what's the derivative of constant? It's 0. And now we have Rx, partial derivative of R with respect to X. So So this is r over here, and we're differentiating with respect to x. So here we do have a x here, so that means this is not going to be 0. And here we have z and y as constant. Okay, so we have z over here, which means this is a constant, and differentiating x as well. So since we have x over here and x over here as well, so this is like two functions together, and for this what do we use? We use product rule. Guys, remember from Cal 1, so the product rule is f prime times g plus g prime times f. Here the function f is the first function and the function g is the second function, cosine of xz. And what's the derivative of the first one? F prime, that's 1. And what's the derivative of g prime? So the derivative of sine is equals to cosine, and the derivative of cosine is equals to negative sine. Okay, so the derivative of cosine, that means it's negative sine. So that's negative sine of xz. And you have this inside function as well, so which makes this into chain rule. So that means you're not done here. You need to multiply this with this inside function as well. So derivative of the inside function. So what's the derivative of an inside function? So inside you have xz. Okay, and remember we are differentiating with respect to x. That means z is a constant. So z is a constant, it's gonna stay over there, and the derivative of x is 1. So you're not gonna write it. Okay, if you're confused, so let me give you something example like sine of 2x. What's the derivative of sine of t? Like if you have something like this and you want to multiply with the inside function, so here the inside function is 2x, and what's the derivative of 2x? It's 2, right? Because this is 2 is a constant and derivative of x is 1. So this is the same thing. So here the z represented as 2. Okay, so that's why it's gonna multiply with it because it's a constant. Okay, so now once you have this, you can just simply write it in a better way, negative z sine of xz. Okay, so now f prime first. F prime we have 1 times g, which is cosine of xz, plus g prime, which is this one, negative z sine of xz, and then times f, which is x. So now let's go ahead and multiply everything together. So here we are left with negative xz sine of xz. So this is our answer for r of x. Okay, so the here, which means p of z should give you the exact same thing, otherwise you have done something wrong. Okay, in order to make it conservative, of course. Okay, so pz, so this is p and you're differentiating with respect to z. Okay, let me write p over here so it's easier for us to see. Z cosine of xz. So we're differentiating with respect to z, which means x and y are constants over here. So here this 2 is a constant. Okay, again this is a product rule. So here f is z, g is cosine of xz, f prime it's 1 since we're differentiating with respect to z, g prime is negative sine of xz, but remember we need to multiply by this inside function. Okay, and c. And what's the derivative of this inside function? So here it's gonna be x only, right? Because the derivative of x is z, it's x only because the derivative of z it's 1 and x is a constant, it's gonna stay over there. So then it becomes negative x sine of xz. So now we have f prime times g for the product rule, right? F prime times g plus g prime times f. This is product rule, and you need to know this by heart. Okay, f prime times g plus g prime times f, which is the cosine of xz negative xz sine of xz. Okay, let's see if we did get the same thing. Yeah, we actually got the same thing, which means our answer is correct for PZ. Now, let's go ahead and find QX. QX. So what is Q? The Q is this equation over here. Okay, e to the power of y. And we're differentiating with respect to x, which means y and z are constant. And there's only y, this is a constant, and there's no x. Okay, so which means this is 0. And py has to be 0 as well. Let's see if it's 0 or not. So this is p, and we're differentiating with respect to y, but there's no y, there's only x and z, which means this is 0 as well. Okay, so which did make our curl of f is equals to 0, which means it's a this vector field is conservative because we get ry minus qz. So if we do this, right, 0 minus 0 I hat, we only get 0 over here. And if we do negative j hat, and here we have this whole equation over here, cosine of xz minus xz sine of xz minus the same thing over here. So we do get 0 over here. Okay, so you simply need to write this equation in this form and show that this is indeed equals to 0 I hat, 0 j hat, and 0 k hat, and which of course gives 0 as the final answer. So the curl f is equals to 0, which of course means the vector field is conservative. Okay, so now here I told you guys they would make it conservative, so we have to do more work, right? So now we need to show ahead and find the potential function and then plug in the function into these points. Okay, so let's go ahead and find the potential function. So once we have proven that the vector field is conservative, our next job is to find the potential function. So if it's proven that it's conservative, which means the function is actually equal, the function that we are given is actually equal to the derivative of the function. Okay, so this the gradient of the function. So the function that you have over here is actually equal to the gradient. And remember gradient. So the gradient is nothing but simply the function with respect to x, function with respect to y, the partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. So this is how it's written. So that means these component that you see over here, this is partial derivative with respect to x, this is partial derivative with respect to y, and the z component is partial derivative with respect to z. Okay, so now once we have this, alright, so I just rewrote the equation over here, the original function that was given to us, z cosine of xz ey x cosine xz. So this is what I wrote over here. Okay, so now since we know that the function is the gradient function, so this means this that you see over here, this is f of x. Okay, and in order to arrive at the original function, which is the potential function, which means the original function, how do we undo the derivative? This is partial derivative with respect to x, right? And how do we undo derivative? Remember, we take integral to undo the derivative, right? So we're going to integrate this function, the gradient function, and we're going to integrate this part in order to arrive at the original function. Okay, so since it's I hat, so that means that we're going to derive this with respect to dx. Oh, I mean integrated with respect to dx. Okay, and if it's this function, that's gonna be with dy, and if it's this function, that's gonna be with dz. Okay, you can take any of this function you want, but it's better to take f of x first, because if you take this first, then you're gonna have a constant of this one, and then it's easier for you to find the constant of these ones later. Okay, so let me show you what I mean. you'll see in a moment what I mean by constant. Okay, so if you derive this with respect to dx, which means y and z are constant over here. Okay, so this is a constant, it's gonna stay over there. And what's the integral of cosine of z? So that if you take the derivative, the sign of the derivative is cosine, and the derivative of cosine, it's negative sign. But here we already have the cosine over here, and we want to undo it, so we're going to go in the inverse direction. So what's the integral of cosine? Then it's sine. So sine of x is z, and now we need to divide it by the derivative of the inside function, because it's a u substitution. Okay, if it's a derivative, we multiply by the inside function, but if it's integral, we divide it by the inside function. Okay, so what's the derivative of the inside function with respect to dx? That's gonna be z. Okay, because the derivative of x is 1 and z is a constant, so stays over there. Okay, so now we can cancel out the z's that you see over here, and here every time you do the integral, remember there is always a plus c, so you're going to write a plus c. Okay, but this c can be something from the y part and from the z part that you see. This is the y component and this is the z component. Okay, we only took into consideration the x component, right? But there's still a y and z component to be left to be considered. Okay, so that means this c has to be something from y and z. Okay, and you can name this anything you want. Let's go ahead and name this g, variable g. So it contains something from y and z. So I name this variable as g of yz. Okay, so this is what we got from by integrating this function. So you're almost done with by calculating the function, the potential function that you need, but you're only missing this piece. Okay, so let me write it over here. So this is almost your final answer, but you're just missing this piece and you need to find it. Okay, in order to find this function, we already used this one, right? So this one is gone. Now we have these two things. So here we can go ahead and use this f of y over here. So we have this f of y, which means partial derivative with respect to y. Okay, this is already given to us, and this is the function. So how about we take the partial derivative of this one with respect to y? So this is gonna become f of y if we take the partial derivative of this with respect to y. And how about we make it equal to this f of y that is given to us? And so like this, we can find the missing piece over here. Okay, so let's go ahead and do this. So we're going to take the partial derivative of this function with respect to y, which is simply f of y. Okay, so we're taking the derivative with respect to y, which means x and z are constant and we're only differentiating y. So you see x and z are constant, so that means this is 0. And now there's a y over here, so this is not 0, this is not a constant. So this is the derivative of this one. Since it's a variable, it's going to become g prime of yz. Okay, so this is the f of y derived from this equation. Now make this f of y that we got g prime of yz. Okay, make this f of y equal to the f of y that is given to us in the equation, which is e to the power of y. Okay, so f of y is equal to the power of y. This is from the equation. This is the one that we found. Okay, let's make these guys equal. Okay, now you guys can, so if we make this equal, we can know that if there was something from here, then we would cancel these things out from this one, but there's no things to be cancelled out there. It is a simple equation, which simply means g is actually equal to the e of y. Okay, so it is simply stating that the g prime of yz that we got, which is equals to the ey. Okay, So but if this is g prime, we're not looking for g prime, we're looking for g. So in order to remove this prime, what do? How do we undo the derivative? We take the integral to undo the derivative. Okay, so now we get g of yz. And what's the derivative of e to the y? And of course we are taking the derivative with respect to dy, right? Because here we took f of y, so that's why we're taking the derivative with respect to dy. Okay, so the integral. Okay, so integral of ey, it's the same thing. And remember, when we take the integral, there's always a plus c over here, but here this plus c, it's gonna be in terms of z, the constant z, because here we took into consideration that there is two constant y and z, and we dealt with the y, and we figured out that the constant of y that belongs to y is e to the y. So we got our y constant already. So now we need to worry about the z constant, which means there is a z constant missing, and here you can again name it anything you want. Let's go ahead and name it g of z. Okay, so you can replace this y of z in this equation here with e to the y plus gz, and now you need to find the g of z. Okay, now to find the g of z, we're going to do the same thing that we did for the y. How about we integrate this function with respect to z now? So we're going to get f of z from this equation, and we're already given the f of z from this equation. So like this, we can find the constant in here as well. Okay, so let's go ahead and integrate this function. Find the partial derivative of this function with respect to z. Partial derivative of function with respect to z, which is nothing but f of z. Okay, so here x and y are constant over here. We're only differentiating z, so the derivative of sine is cosine xz, and times the inside function, we're differentiating with respect to z, so the derivative of z is 1, and the constant x remains over there, and this is a constant, so the derivative of e to the y is 0, and g of z, that's not a constant because it has z in it, so that's gonna be g prime of z. Okay, so now that we got our g of z as cosine xz plus g prime of z, now what about we take it and make it equal to the f of z that is already given to us from the equation. So from the equation we have x cosine xz. Okay, so from the equation we have x cosine xz. Okay, so this one is from the equation. Remember? This is from the equation. So now let's make these two guys equal to each other. Cosine of xz that we found over here equal to the x of z that we got from the equation, and you guys see we have something to cancel here because these two are equal. So let's go ahead and cancel this. So what is our g prime of z in this case then? This is equals to 0. Okay, and we are not looking for g prime of z, we are looking for g of z. So what do? We're going to take the integral, and if we take the integral, this becomes g of z, and the integral of 0 is nothing but a constant c. Okay, so then g of z is nothing but simply a constant z. So you can finally make this equation, so then it becomes plus c, and this is your final answer for the potential function. So now let's go ahead and find this potential function, and with the work done moving a particle from these points from 0, 0, 0 to pi over 2, 2.5. And we're going to take this function and evaluate it from the given points. So our points that we have over here, we're going to do f of b minus f of a, and the point b that we have here is pi over 2, 2.5, and point A that we have is 0, 0, 0. Okay, so the second point is point B, and the first point is called point A. So we always do f of B minus f of A. So let's go ahead and plug in the points. This is x, y, z. So first we have sine of x is z. This is x, this is z. So that's pi over 4 sine of pi over 4 plus e to the power of 2 plus c and minus that is f of b, right, and minus f of a. So you're going to plug in a inside this equation. So sine of 0 plus e to the 0 plus c. So then this gives you square root of 2 over 2, or you can leave it as sine of pi over 4. And now e to the squared plus c, and that's negative. Sine 0, it's 0, and e to the power of 0, it's not 0, remember, it's 1. Okay, so here the negative is going to multiply each one from here, so that this is going to become negative sine of 0, this is going to become negative 1, and this is going to become negative c. So you have negative 1 and negative c. C and c cancels out, and you are left with this, and this is your final answer for this question. Okay, so let's go ahead and solve this question over here, which says reverse the order of the integration of this one. Okay, so for this, remember, you need to know that since you're differentiating this with respect to dx first and then dy, so this means these values are x equals to something and x equals to, and here this is y equals to and y equals to. So you got your equations as, your first equation is x equals to y squared, your second equation is 2 minus y squared. So you're going to make a graph of this equation and then figure out the bonds of this in order to swap it. Okay, now, okay, so I just did the graph. So now we're going to graph this. Okay, so I hope you understand what we are doing. So what we're doing, we're given the function, we reverse the order of the integration, which means this is given into dx dy, so we need to make it into dy dx. Okay, so this means this has to be y equals to something, y equals to something, and this has to be x equals to something and x equals to something, and our job is to find out these values. Okay, for this, first let's go ahead and make the graph of this one. So this is given in terms of x, the first equation. So let's go ahead and make it in terms of y by square root the both sides. So if we square root the both sides of this square, and square root cancels out, so we're only left with y over here, and is equals to x squared. So this is our first equation, y equals to x squared, and as you guys already know, this is nothing but a parabola. Okay, now for the second equation. The second equation, in order to find y, we need to just make some algebraic manipulations over here. So this is our second equation. We have x equals to 2 minus y squared. In order to isolate y, we're going to square both sides. So there, here it becomes 2 minus y squared, that was squared. Yeah. So here the square and square root cancels out, so we're left with 2 minus y squared. So now we can make this equation go to the other side. So x squared minus y squared is equals to 2. So now, does this equation seems familiar to you? Yeah, you guys already know this equation. This is an equation of a circle centered at 0, 0. Okay. So here, the equation of the circle, when it's centered at 0, it's equals to r squared, right? So here, if you had like 9 over here, then the radius would be 3. But here you have 2 over here, which means the radius of this one is square root of 2. Okay, so here the radius is equals to square root of 2, and you need to know this in order to draw it. Okay, so here you're going to make a circle with the radius of 2. So let's just say you made a circle like this. Okay, Okay, so yeah, you need to make a good circle. Here I made a really bad circle. It doesn't even look like it has a radius of pi over 2. Square root of 2, I mean. Okay, let me try to make another one. Okay, yeah, this one is a little better. Here you can see it has like an equal radius. Okay, so here this has to be square root of 2, this has to be square root of 2, this has to be negative square root of 2, this has to be negative square root of 2. Okay, now since it's centered at 0, and here you guys can see the intersection of these two, so it is this region over here. Okay, so that means we only need to worry about this region. The rest of the region we can remove it, we don't need it. So let me remove this. Okay, so we only need to worry about this region. Okay, now once we know this, we need to know the values of y. Okay, and we know it's an equation, and here the values of x is not an equation, it has to be a point. Okay, and what about we do for the x first, because we already know the values for x. Okay, so for x we know that it has to be a constant. Okay, so it goes from, you're only going to look at the values of x where does the region belongs. Okay, so the region belongs from 0 to square root of 2, and the lower bound is 0 and the upper bound is square root of 2. So these are your values for x. So it goes from 0 to square root of 2. And what about for y? For y, you're not going to look at the values like negative square root of 2 and 2. No, that's going to give you the wrong answer, because this is not the constant. Okay, always the last variable is constant, but the all the inner values are not constant, they are an equation. Okay, so in order to find this equation, you need to remember, if you're going in the dy direction first, you go in this way in the graph, but if you're going in the dx direction, you go in this way. Since we're going in the dy direction first, we're going to go in this direction inside the graph. Okay, so inside the graph we're going to go like this, like this, like this. Okay, so now you need to know the equation of this line. So let me choose another color so it's easier for you to see. Okay, so I chose the color green so it's easier for you guys to see that we're going in the dy direction like this. So we need to know the equation of this part and the equation of this line. Okay, so when you were drawing, remember we drew a parabola first, so that means the equation of this line, it was a parabola, right? So the equation of the parabola is y equals to x squared. Okay, and what about the equation of this line, the top of the arrow? So you always need to know the equation of the bottom of the arrow and the top of the arrow. So the bottom of the arrow, you got it y equals to x0, and what about the top of the arrow? So what is the equation of this that you see over here? So this was actually this equation, right? But it was an equation of a circle. Remember here? Yeah. So here you need to know the equation of this one, but here you are given this equation in terms of x, and we need it in terms of y to be able to put it over here. We need y equals to something, but we have x equals to something. So let's go ahead and find this equation from y equals to something. Okay, so here we need to isolate y. So in order to do this, let's make the x to the other side. Okay, and now getting rid of this negative, so we get negative 2 positive x squared. Okay, and then yeah, we do have the square over here, so let's square root the whole thing, square root both sides, I mean. So here we're left with y, and here we're left with negative 2 plus x squared. Alright, so we got this equation over here for the y. So yeah, just to make it look a little better, let's move the x. Okay, so now it looks better, x squared minus 2. Okay, so we got our second equation. this equation as x squared minus 2 square root. So this is our lower bound, okay, this equation, and this upper bound is this equation, okay. So we got our lower bound as x squared and our upper bound as x squared minus 2 square root of 2, okay. And here I have just realized I did a mistake here in the x values. This doesn't have to be square root of x, because when I was looking at the x values, I was not here in the graph. I was not looking at the x values here. I was looking at the y values for some reason, and I'm sorry for that. So here we need to look at the x values. Where does the region belong in the x direction? Okay. So here you guys can see that the lower bound is 0, which is correct. But the upper bound here, it's not square root of 2. It has to be this value over here, which is actually the intersection point of these two graphs, okay. So we need to figure out this value over here, the intersection of two graphs. Oh wait, I have just realized I did a little mistake over here. This was negative y squared, so if you move that to the other side, this has to be a positive y, okay. So then this is gonna make an equation of a circle. I'm so sorry for that. So then this is positive y squared, so you don't have to change the signs, that means, okay. So no changing of sign, so that 2 minus y squared, okay. So then here this has to be 2x squared negative x squared positive 2, okay. Negative x squared and positive 2. Just have to swap the signs. Negative x squared positive 2, and here as well negative x squared and positive 2. I'm so sorry for the mistake. Okay, now in order to find this value over here, we need to find the intersection of these two graphs, okay. So we're going to take the equation of these two graphs. We are finding the intersection point, okay, and we have this equation over here as y equals to x squared, and the other equation as y equals to x squared plus 2, okay. Sorry, negative x squared, I forgot. Negative x squared plus 2. Okay, if you want, you can take these two equations as well, but I prefer taking y equals to, okay. Now, in order to find the point of intersection, we are going to make this equation equal to each other. So now, if you square both sides, okay, here you're going to get x to the power of 4, and here square root and square root is going to cancel out. So you're going to left with negative x squared plus 2 x to the power of 4. And if you move the 2 to the other side, so you get positive x squared is equals to 2. But in order to make this equation in terms of like ax squared plus bx plus c, you can move the 2 also to the other side. So if you move it to the other side, you should get negative 2 plus 2 0, okay. You see now this equation in terms of this one. Now in order to find in order to expand it to be able to solve it, right, to solve for x, we need to find two values r and s, such that we're going to multiply a times c. It's good. If you multiply a times c, you need to find this r and s. It's equals to a times c, okay. And if you add these a r times s, it should be equal to b, okay. So a and c, what are the values of a? So this is 1, and the value of c is negative 2. So if you multiply a times c, 1 times negative 2, that is equals to negative 2. And what is the value of b? So the value of b is 1. So what are these two values? If you multiply them, it gives you negative 2, and if you add them, it gives you 1. So the values are negative 1 and positive 2, okay. So you got these values. So now you can expand this equation over here. So here you get x to the power of 4, and here you're going to replace this with this r that you get over here. So negative 1, so that's going to be negative x squared, and here you got positive 2, so positive 2x squared. So you just expanded this using this values. Okay, so if you add these negative x squared, positive 2, it does give you 1x squared, right? So now we have this equation. Now we can go ahead and factor it. What can we factor from this equation? So we can factor an x squared from this equation. So we're going to get x squared and negative 1 here. And what can we factor from here? We can factor a 2 from here. So here we get this, and you guys see we get these two equations exactly the same thing. So let's go ahead and put this here. And we can combine this and this over here. So let's go ahead and do this. So x squared plus 2. So we got these two equations here. These were same, so we put it over here, and these we put it over here. This is simply high school math. Okay, now we can make these two equations equals to 0 separately. And if you do this, x squared is equal to negative 2. Okay, and you cannot find a square root of a negative number, right? So this is wrong. It gives no solution over here. And if you move on here, this becomes positive 1 if you move the negative 1 to the other side, and you have square, and the square root of 1, that gives plus and minus 1. Okay, so you got your intersection point that you were looking for in terms of x. It is negative 1 and positive 1. Okay, so here the intersection point that you were looking for here for the x, it's positive 1 here, and here it's negative 1. Okay, so here if you look at it, if you look at it carefully, and the region doesn't go from 0. The region, actually the lowest value for the x for the region is negative 1, and the highest value is 1. So that means you need to change this 0, and these values has to be negative 1 to positive 1, and this completes our question, and this is the final answer. I hope you like this video. Thanks for watching. Bye.